Welcome to the CHMT4012 Drilling Fluid Presentation. The purpose of a drilling fluid is to remove drilled cuttings from under the drill bit, carry those cuttings out of the hole, suspend cuttings in the fluid when circulation is stopped, release cuttings when processed by surface equipment, allow cuttings to settle out at the surface, provide enough hydrostatic pressure to balance formation of pore pressures, prevent the borehole from collapsing or caving in, protect reducing formations from damage, which could impair production, and finally to clean, cool, as well as lubricate the drill bit. The choice of drilling fluid for any operation is therefore incredibly important. Thus, every aspect of a possible drilling fluid choice must come under scrutiny in order to achieve a successful drilling operation. I believe our product would be the best for all your drilling needs. Our product is a water-based fluid with very few additives and long-chain polymers used. The first thing to consider when choosing a fluid is the fluid type. The type of drilling fluid to be used is determined according to the temperature and pressure of the drilling well. The common types are either oil-based or water-based fluids, but others, such as synthetic-based, have also been used. The product to be considered is water-based, which is defined by the suspended solid particles in water. This type is the most commonly used. The composition of the drilling fluid makes it environmentally friendly and allows it to remove the drill cuttings with ease. Formation of the drilling fluid. The water-based drilling fluid is comprised of a continuous liquid phase, which is water or a brine solution, the colloidal fraction, which is made of bentonite, about 0.05 to 1 micron, and the inert fraction, made of barite, which is about 1 to 50 microns. Bentonite is used in the colloidal fraction to enable control of the drilling fluid, while barite is used as the weight material because it allows for the use of very few solids to maintain the desired fluid density. The steps that are followed in order to prepare the drilling fluid are as follows. Number 1, the makeup water is treated. The quality of the makeup water is one of the most important factors in making high-quality drilling fluid. Warm, soft water is best suited. This is done by heating up the water to between 20 and 40 degrees Celsius and adding soda ash, also known as sodium carbonate, to reduce the hardness and raise its pH to around 8.5 or 9. The next step is to introduce the bentonite clay. Extended bentonite, which increases the viscosity of the drilling fluid, thus giving extra gel strength, improves the carrying capacity of the fluid, and reduces fluid loss, is slowly added to the treated water with good agitation. Step 3 is to add the necessary polymers. Polymers are helpful when drilling through clays to prevent the clays from sticking together and bitballing. They can either be short or long chain polymers. For this fluid, long chain polymers are used as they provide a lot of viscosity. And finally, step 4. This is where we add the specialty additives. Specialty additives that can be added include drilling detergents, dispersants, and lost circulation materials. The additives used in this product are surfactants or foamers with viscous and elastic characteristics, as well as soda ash to remove calcium, control the alkalinity and pH, as was mentioned earlier, and to increase the viscosity as well, and improve the whole cleaning. Product toxicity. The toxicity of the product is also a consideration. This is due to the possible impact it may have on the environment during the drilling process. Due to the type of fluid, being water-based, there is very little toxicity in the makeup of the fluid. The basis of using water is very environmentally friendly, with only some of the additives potentially causing problems, such as the long chain polymers being used. The polymers will, however, be sparingly used, thus minimizing the impact on the environment. Next up are the rheological properties of the fluid. There are 4 things to consider, which are the gel strength, plastic viscosity, yield point, and thixotropy. First up is gel strength. Due to the fairly low viscosity of the fluid, the gel strength is considered to be low to moderate. This is, however, an acceptable margin. This is because gel strength increases with the addition of drill cuttings. Next is plastic viscosity. The product has a low plastic viscosity, which also helps with keeping control of the gel strength. This means that the pressure drop will also be low, and there will not be much resistance to flow. The third point is yield point. This is dependent on the amount of solids that initially gather in the fluid, which obstructs the initial flow, and can vary, but it is predicted to be fairly low for this fluid. The last point is thixotropy. This property may affect the fluid quite heavily, dependent on the flow rate of the fluid and the amount of bentonite present. This is due to the water base used for this type of fluid. A little disclaimer, these are just suspected behaviors. Thus, the only way to accurately know how the fluid is behaving is by using a viscometer or a rheometer at the actual site. So, why is our product the best? This product is the best due to a number of factors. Number 1, it is cheaper to produce and purchase compared to the other types of fluid available. This is due to the water basis used. Other fluid types, such as oil and synthetic based, are more expensive since they use more expensive basis materials. The other types also generally require more additives to reduce their viscosity, amongst other things. Thus, this drives the price further up. Number 2, it will accomplish the functions mentioned previously that are required of it for a drilling operation. Every single requirement is used as a baseline for the effectiveness of the fluid. If it misses just one of these requirements, then the drilling fluid is considered a failure. We believe our product, with the right implementation, will continuously hit every single requirement perfectly. Number 3, the number of additives is minimal. They mostly include the need to increase the fluid viscosity and control pH or alkalinity. The basis is also water. These characteristics thus result in very little toxicity and proves their product's environmental friendliness. Number 4, the lack of additives and water bases make it a lot easier and simpler to produce. Therefore, there will always be sufficient supply for any drilling operation, no matter how long. This is, of course, in comparison to other types of drilling fluids. And finally, number 5. Due to the nature and characteristics of the fluid, its ease of use too, this fluid is easily tailored for a wide variety of drilling operations, whether it be on land or at sea. So in conclusion, we ask you to please seriously consider this product exclusively for your use. It will benefit you highly and improve your drilling process tenfold, thus turning over a greater profit. You will only be satisfied by what this product has to offer you. Thank you.